Yep, fund. So the sticker price is you're gonna take the base price, you're gonna add in the options. Do you know what a destination charge is? So destination charge means that they're gonna, you found a vehicle you want, but like you're living in Indianapolis right now, maybe it's over in Columbus, Ohio, and what's it gonna cost to get it from Columbus, Ohio to Indianapolis?
Oh, okay.
You know when you see those semis
Like
drive in with the,
trans-
yeah, to transport it. But you know when you see the semis drive in with like the 8 cars stacked up behind them, that's what they're doing. They're transporting cars.
They're towing trucks and stuff.
Not necessarily. It's usually they're transporting new cars. Sometimes they have cars that have been in an accident and need to be junked, but usually they're transporting new cars. So let's look at this option then. So we've got, so what was our base price?
The base price is $23,785.
Correct.
And then the factory installed option total is, so options up there, that's, you're adding that.
Yep. And so those options are extra things like how it looks, or if you want to add the air conditioning or power steering, or if you want to have automatic windows or a CD player, all those fancy things that get at my car has seat warmers, and that was when it was new, that cost a little extra for them to put that in. So does that make sense?
Everything like costs nowadays to get a special extra.
Oh yeah,
effects in your car.
you gotta pay for all that stuff. So this person put in a lot of extra options. They probably have heated seats and power windows,
MP3 hookup and stuff.
Oh yeah, that's a big one. In exponential, those y values are going to be multiplying or dividing the same thing every time. All right, so if you're looking at a table, oh no, my marker's dying. You've got x and y, and let's say x is just going up by 1. That's usually what you're going to see, is that x changing by 1. If y is going 3, 6, 9, 12, what would that be, linear or exponential? Look at your y's and ask yourself, what's happening every time? What's happening every time? What are they doing? Multiplying by what? How do we get from 3 to 6 and from 6 to 9? Well, from 3 to 6 we can multiply by 2, but then 6 times 2 is 12, not 9. So that one doesn't work because it doesn't happen every single time. How else can we get from 3 to 6? Add 3. How do we get from 6 to 9? Add 3, and then add 3 again. So since we're adding something every time, we're going to say that this one is linear. So when they talk about justify your answer, it means tell me which one it is, but then tell me why. It's linear because they're adding 3 every time. Let's say you've got 2, 4, 8, 16. Now, how do we get from 2 to 4? Multiply by 2. How do we get from 4 to 8? Multiply by 2. So you need to make sure that you don't just look at the first one and make the assumption that, oh, it's going to work for every one. Because you could also say, oh, we add 2. But wait, here we add 4. So that doesn't work. So instead, we're going to say, okay, I can multiply by 2. And then if it works on all of them, that's when you can say that. So which one is it? Linear or exponential? Exponential. Why?
Because it's multiple.
So tell me which one it is and then why. So then, have you looked at the graphing at all? There's some graphing problems on here. Have you looked at how to graph yet? If not, it's okay.
I just kind of
Okay.
looked over.
That's fine. Okay, so you're going to be given some functions that you have to graph. And what we're going to do on these is we're going to make an XY chart. So the values we're going to pick for x typically are going to be -1, 0, and 1, because those are the friendliest numbers to use. It really doesn't matter which numbers you're using, but those are just the easiest to plug in. And they're going to give us nice whole numbers usually, or close to whole numbers. So, hey guys, make sure we're getting work done, please. Thank you. So we're gonna plug in that -1. What does a negative exponent do? Well, it's like this right now, and so when we have a negative, we flip it. So what does this become? I'm gonna flip that around.
1/4.
Yeah, 1/4, because it's like this is over 1. So we're gonna say we have 1/2 times 1/4. Okay, now with multiplying, we can multiply straight across. 1 times 1 is, 2 times 4 is,
8.
yep. So we have the point then, -1 1/8. Okay, so we'll look at that on graph paper here in a second. Let's plug in 0 now. Okay, anything with a 0 power?
0.
Not 0.
1.
Anything to the 0 power is 1. So x to the 0, 1. 100 billion to the 0, 1. All right? So that, and that's why we like using 0, because it basically makes that go away. So we're just going to have 1/2 times 1, which would just give us 1/2, because anything times 1 is just itself. So now we have the point 0, 1/2. And let's plug in one more point. So we've got 4 to the first power. So we have 1/2 times anything to the first power is itself. So we're going to have 1/2 times 4, and half of 4 is what?
2.
2. So then we're going to have this ordered pair here. 1, 2. So then if you're looking at a graph, we're going to have the points -1, 1/8. So what we're going to do is we're going to go x -1, but then we're just going to go up a little bit off of 0, but not all the way up to 1. We're going to go over 0, up 1/2. And then we're going to go over 1 and up 2. And so you can see it kind of gets a little bit bigger there, but then it really starts to kind of take off. So your shape should always kind of have this look to it, where it's going to really take off in one direction. In the other direction, it should get really close to that x-axis, but it should never